All right, guys, today's lesson is on dimensional analysis, and this is another super important topic. We'll be using this all year long, and yes, will continue using that concept of sig figs now in calculations in a way that's known as dimensional analysis. So you know the drill: notes, handout, calculator, pencil. I am ready to go. So dimensional analysis, a scary word, hopefully not too scary eventually concept for you guys. So what is dimensional analysis? Dimensional analysis is a method used to convert from one unit to another, usually outside of the metric system. We know here in the United States we do weird things like have like inches and feet and pounds and stuff like that, which is not a direct conversion of moving the decimal in terms of tens, hundreds, thousands. It's not as simple as that. Okay, so we need a different way to figure out how to go back and forth between one unit to another. It's based on the understanding of something called equalities and how they allow us to create conversion factors. Okay, you're really like, what is an equality? Well, I have the definition for you. An equality is something that states the same measurement but just in two different ways or two different units. So looking here, I have a string. I have started to measure this string at a 0.0, right? And looking at this same string, depending on what measuring instrument or what measuring ruler I have, I can measure its length as 10 inches, or I can measure its length as 254 millimeters. Those are different units, but both represent the same thing. So here are some examples of equalities. You don't have to write all these down, but these are some common ones that you may know, okay? To go between feet and inches, well, we know in 1 foot there are 12 inches. Those two things are equal, yes? Okay, we know 1 inch is equal to 2.54 centimeters. A gallon is equal to 4 quarts, 1 meter is equal to 100 centimeters, and a kilogram is equal to 1,000 grams. Okay, these two things, these two values are equal. Okay, so let's bounce down to the document camera and kind of unpack the rest of the lecture on this paper. Okay, so we said an equality states the same measurement in two different units. Yes, that is hopefully what you have written down. So let's kind of just write a few of the equalities that we saw on that last slide, just to kind of give us some examples here. So one of them that we did was 1 foot is equal to 12 inches. Those two things are equal, right? We could also say 1 inch is equal to 2.54 centimeters. And like I said, metric is available for you. There was an example on there, 1 kilogram is equal to 1,000 grams, okay? So we can take these equalities and we can turn them into what are called a conversion factor. A conversion factor is an equality, but it's expressed now as a fraction, okay? The two values are still equivalent, so they're still the same. So it is equal to 1. Okay, and if you're like, I do not understand what she means by that, it's fine, we can move on with our life. So what we're actually going to do is we're going to take these equalities that we wrote up here and we're going to write them as conversion factors, meaning I'm going to take one guy and he will be on the top of my fraction, and then the other guy, he's going to be on the bottom. Okay, so I just put 1 foot over 12 inches. Okay, since we are saying that those two values are equal, that's what I mean when I say it is a value equal to 1. Anyway, okay, and you're like, well, why did you decide to put the foot part on top and the inches part on bottom? It actually doesn't matter. We're going to have a conversation of why the flipping is a potential thing for you to get to do here in the future. But we could also write this inch to centimeters thing as a conversion factor. I could write the 1 inch on top and then the 2.54 centimeters on the bottom, right? I could also do the 1 kilogram and the 1,000 grams on the bottom. This is just saying these two things are equal. So 1 kilogram is equal to 1,000 grams. And I said you can flip if needed. Okay, and you were like, flip if needed. Needed for what? You were just telling me something. Are we going to use this for something? Yes, we are. We're going to use this in calculations. So steps for solving problems with dimensional analysis. I am going to blast through these super duper fast because it's just words on a page that I merely want to have on this page to where if you get really lost, you have words to go back to kind of guide yourself. But most of this, you're never going to look back at again. You're going to kind of get the concept from the practice that we do. So here's the steps. Write the given value and unit you're starting with and put it over 1. Identify which equalities are needed to convert to the final unit and make a unit plan to get to that unit. Multiply your given by each conversion factor in order of your unit plan. And for each conversion factor, the unit that you currently have will go on bottom. So we have to write something there. And the unit that you want to get to will go on top. The conversion factors will cancel out unwanted units until only the unit you want is left, okay? Then we multiply all the numbers on the top, and then we divide by any numbers that we have on the bottom, okay? And then we're going to write our final answer with, oh, y'all are ready for this, correct sig figs. Here they come back again, and units, meaning values like inches or feet or something like that, because these are all measurements. Okay, we're going to take it slow. We're going to start with one-step problems, and then we're going to do some more fun, complicated multi-step problems. Okay, how many centimeters are in 6.00 inches? Let me tell you something. You guys get real squirrely, and a lot of times you have like no concept of where you were going to and where you were starting from. I got a real quick, easy trick that's going to make your life amazing for the rest of my class. I zone in on numbers in my problems, and I immediately circle them. Not only am I going to circle that number 6.00, in chemistry, we study unit stuff with units, measured values. I'm going to circle my number and the unit after it. That is my given, meaning in any calculation in my class, that is where I'm starting, okay? To figure out what I'm solving for, I box off that in the word problem. How many? Centimeters. We are solving for centimeters. You know that Mrs. Sabaka does not like to read, so with this information, I only have to look back at the problem and be like, okay, the circled value is where I'm starting, and I'm going to centimeters. I do not get confused. So I can use that to kind of make a unit plan, meaning I know I'm going from inches, and the purpose of this mathematical problem is to get to a value that is in centimeters, okay? So what I'm going to do is I'm going to do what's called a train track, okay? A train track is you go on a journey through a conversion system, okay? So I know that I can actually look back up. We even wrote this, how we relate inches to centimeters. We said in every 1 inch there are 2.5 centimeters. We even wrote that equality as a conversion factor. We're going to use that and plop it on our train tracks to complete our journey to convert from inches to centimeters. Let me show you what this is going to look like. This, you may be like, what is she doing here? Just wait and watch, okay? Our train tracks are going to look like this. So draw that. On any train track, no matter how many steps it is, your given will be written right here, okay? A train moves from left to right like you're reading a book. So we're going to move through our journey this way until we get to the unit that we want at the end. We said there was a conversion factor for us to use to go from inches to centimeters. We are going to plot this down here in a way that makes sense. Let me see what I'm talking about. Let's go ahead and write my given here. My given was 6.00 inches. Don't you dare write that number without any units. You will get lost, you will get the problem wrong, and you will make me mad, and you're not going to get no credit because it's not appropriate work shown. This is inches, not monkeys, not feet. It's 6.00 inches. And the reason why it is important, besides not wanting to make Mrs. Sabaka mad, is that is going to let me know, well, which way I flip that guy. I have always got to flip my conversion factor to where the unit that I have on top of the previous step or of my given matches the unit in my conversion factor that I have on the bottom. So I have got to write this conversion factor with the inches part on the bottom, which means 1 inch goes there, and then the 2.54 centimeters goes on the top. Okay, the reason why we do this is that inches now cancels out. The only unit I have hanging out left here is centimeters at the end. Well, great, that's where I wanted to get to. Okay, now you're like, what does this even mean? She's got lines in it. She said we were trying to do math. Now, maybe in your math class, you're used to maybe handling something like this. Y'all have probably done something like that. It's we're multiplying fractions here, okay? In a lot of chemistry classes, you'll see it just represented as lines because it's a little bit easier, but that's all that we're doing, you guys. So if I were to actually do this math, I multiply by anything on the top and I divide by anything on the bottom, okay? And as I mentioned here, or as I demonstrated here, this 6 is technically over 1. You do not have to write the 1, but that, if that makes you feel better and reminds you that you're actually just multiplying fractions together. All right, so all I have to do is I have to multiply these numbers together, and we're getting really excited. So I have 6 times 2.54. Okay. We know we're going to have to do some rounding with some sig figs because we are technically multiplying, okay? Let's just write this number that our calculator gave us on the paper just so we can practice a good rounding with sig figs conversation. That's my answer that my calculator gave me. We know since we have multiplied, I have got to look at how many sig figs that are in the values that have been given to me. Here is a trick though, and you're going to love this. With any dimensional analysis problem, any number that's within a conversion factor, meaning that 2.54 and that 1 right here, are known as infinitely significant. That just means you are sure that they're exactly 2.54 centimeters in an inch. Okay, that was not rounded up to that. You could even say they're 2.5400000. I could have thousands of sig figs in that number, and I would, but that would be inconvenient to write that, okay? Basically, that was a long story of just saying the only number you have to look at for sig figs that will determine how many sig figs are in your ending value is that number right there, your given value. Okay, so your given value has 1, 2, 3 sig figs because we know those ending zeros are significant because there is a decimal in the number. So that means my rounded answer, or my answer over here, I have to round to 3 sig figs. So I want the 5, or the 1, the 5, and the 2. So you're like, yay, that's my answer, correctly rounded. I'm super excited, and you walk away. No, that is a wrong answer. That means nothing to me. 15.2 planets, 15.2 pencils. No, 15.2. Oh, I've forgotten. 15. Well, no, you're not going to forget because you wrote your units here. The only thing that you haven't canceled off is the units, and it should be the thing that you have been asked to solve for that I've boxed off over here from my word problem, which is why I boxed off my answer over here. All right. We're going to do the next one a little bit quicker. It says express 2.0 centimeters in inches. I circle my given with the unit, and I box off what I'm trying to solve for. So this is similar to the last problem. I still have centimeters and inches somewhere in there, but it's having me go in the different direction. I'm converting from centimeters to inches. Okay, we know we can accomplish that in one step. We probably know we're going to be using the exact same equality or conversion factor that tells me how many inches are in a centimeter, but maybe since we're going in the opposite direction, we may have to do something like flip it. Let's see. All right, so our train track, our journey that we're ready to chugga through, our given always goes on the top here, 24.0 centimeters, right? We're going to chugga to do something here that will get to me closer to inches. Whatever I have on top here, I need to write on bottom here. Centimeters, that means centimeters is here, okay? Oh, well, the 2.54 is however many centimeters, and we know that that is equal to 1 inch, okay? I check myself, boom, boom. This will allow me to get to inches because inches is the only thing I have not canceled off. This one is a little bit different because the way my conversion factor is oriented, I now have something on the bottom. That's like having a bottom part of your fraction, something in the denominator, which means we would have to divide by any value that is not a 1 that's on the bottom, okay? So I have, here we go, 24 divided by 2.54. is equal to that, okay? So you can either write a lot of that number down if you don't feel confident in your rounding in your head, or we're gonna see if we can try to round in our head. Regardless, the only number that I have to look at sig figs for is my given. That number has 3 sig figs. So I'm gonna round this answer to 3 sig figs. So I will have 9.45. And the units for this are the only thing I haven't canceled off, inches. All right. So basically the mentality here is as we're chugga going on the train track journey here, any numbers that are on the top of any future conversion factors, and yes, we may have some more coming up, we multiply our given by. Any numbers besides ones that I have on my bottom here, I divide by each time, okay? Obviously, ones play no entrance mathematically. So yes, you can think of the mentality in this first example as 6.00 times 2.54 and divided by 1, but you will not get anything different than what we just did together before. Anyways, long tangent. Let's go to the multi-step problems because these are kind of super fun. So we can string many conversion factors together in problems that just require more than one step. Let's see the example. You are already overwhelmed. You see a number in that problem. I'm not even caring that anything about Susanna. I mean, I do care. She sounds wonderful, I guess. But I see a number and I see the units. I'm starting at 5.50 feet. They want me to figure out what her height is in millimeters. I need to somehow convert this 5.50 feet to millimeters. I have given you some possible conversion factors to use. And by the way, if there are like conversion factors that you do not know immediately in your head that are like obvious, I will provide them for you. I'm not expecting you to even know 2.54 centimeters are equal to 1 inch. But the thing is, I'm looking at these to first see if I can go directly from feet to millimeters in one step like I did here. Is there anything that has feet being equal to a certain amount of millimeters? I don't see that. So we've got more than one step. Where do we start? Which one do we grab first? Well, I got to get out of feet, okay? So I'm going to pick a conversion factor that somewhere in there has feet or a foot, right? Okay. Oh, that one. 1 foot is equal to 12 inches. So we are going to have to use this first. This will be our conversion factor number 1. So if I wanted to create a unit plan, which is a little bit more helpful when I'm doing multi-step conversions, I'm taking this first from feet 2 inches, okay? That is actually the first conversion that I'll need to do, and we'll be using that conversion factor for that step. Okay, well, that would get me to inches. End goal is getting to millimeters here. Inches, what can I get inches to millimeters directly? No, but I can't get from inches to centimeters, so we're gonna have to do that, inches to centimeters, and we're gonna use that guy as our second conversion factor, right? So this is step number 2. Still not to millimeters. Please, is there something to get me from centimeters to millimeters? Yes, there is. There are 10 millimeters and 1 centimeter, okay? So to get to millimeters, we will be using this last conversion factor. So this is a 3-step problem. Yes, still train tracks, except I will have some space on my train track, whatever they're called, rails, lines, rungs, I don't know. So what it's going to look like for a 3-step problem, it's going to be a little bit longer, is my given always goes there. We know my given is 5.50, right? And then my conversion factors in some order are going to go here, okay? Since I have 3 steps, this will be where step number 1 is. This will be where step number 2 is. And this section here will be where step number 3 is, okay? You were like already freaked out. Do not be freaked out because we can do these hard things. We're going to take it step by step and we're really going to focus on our canceling things on top and our bottom. That is the goal or the secret to all of this working out successfully. So our given is 5.50 feet, right? Okay. All right. What am I doing? Well, we said our first step, which I'm putting here, is going to use that conversion from feet to inches. Whoa, I'm going to use that, but write it as a fraction, but careful. I've got to write it as a fraction to where the unit that I had started with needs to go on the bottom. Well, that's feet. So I need to write the 1 foot part on the bottom and then the 12 inches on top. Before we move on to the next step, you must cross off to make sure you've set it up correctly, because if you've accidentally flipped it the wrong way, everything else is going to be completely wrong. So this lets me know, oh, now I made it to inches. I'm right here in my unit map. Well, now I need to use inches to centimeters with this conversion factor. The unit that I have on top here needs to be on bottom, so I have to grab the 1 inch part to put it on the bottom, and then the 2.54 centimeters is going to go on the top. Canceling off my units as I move through my chugga train track journey. Now I've made it to centimeters. I am here. I'm ready for the last and third step, right? So going from centimeters to millimeters, I'm using this conversion factor. I need centimeters down here so I can cancel off. So I'll put the 1 centimeter is equal to 10 millimeters. Cancel, cancel. We love that. And am I done? Yes, I know I'm done because everything else is canceled off nice and perfectly, where the only thing I have left hanging at the end is what I'm asking you to solve for. So we are ready to go. We've got a multi-step journey. It is not a big deal. Keep in mind, everything on the top, I just multiply. Hit multiply what? Multiply what? Multiply what? Everything on the bottom is not that is not a 1. You would divide by each one of those things. But in this problem, everything is a 1 because I wanted to keep things a little bit simple since we were first learning this concept for the first time. So I have 5.50 times 12 times 2.54 times 10. Yeah. Okay, amazing. If we want, we can write that number down as is. We do know we're going to have to round it, but this may be a sneaky rounder. So I'm going to have that written down so I don't have to keep referring to my calculator. All right, we know all of these conversion factors. Thank you, numbers, for doing the math for me, but I'm not looking at you to round. I'm looking at my given value. How many sig figs are in this given value? 3, right? So that means I need to round my answer to 3. Start from left to right, grab the first 3 sig figs. Those are the only ones I want. You're like, cool, 167. I love that. Sabaka, I am so smart, but oh, no. Oh, she almost caught me. It's not 167. I know now. I have to round that 7 up to an 8, so 168. Amazing. Walk away. Woo! Except that's wrong. You're like, how is that wrong? That's 3 sig figs. I rounded the 7 up to an 8. Lovely. But what you have done is you have taken a number that is roughly like 1,600-ish and said a rounded of 1,000-ish. 600 is now 168. Those are completely different numbers. So in your rounding for sig figs, make sure that you still keep these guys in their place value. I still want that 1 to be in the thousands place. I still want that 6 to be in the hundreds place. So to prevent him from scooching on back, you need to pop a 0 at the end to retain everybody's place value. You're like, but I needed 3 sig figs, and now you put a number there. Well, remember the rule with my ending zeros? As long as there is not a decimal in the number, this number still has 3 sig figs. So congratulations. But before you walk away, make sure you pop the units at the very end. The units are millimeters. What I did not cancel off and what I'm asking you to solve for. Okay, now in terms of work required, I know we did a lot of colorful like doodling around here. What I am looking for is numbers on train tracks with the units following every single number. I need to see that. Since we are getting started off, I'm going to actually require you to cross off, because y'all get real weird when you don't cross off because you think you know better and then you make mistakes. So yes, we're going to cross off. I need to see that. And then I need to see your answer rounded to the appropriate sig figs according to what your given is with the units at the end. Okay? So the next one, we're going to go a little bit faster. I may not even use my unit plan. If you need to, that is super duper fine. We'll see what I end up doing. I'm not quite sure. Regardless, I read the problem, lots of words. Where is the number that tells me my given starting information? 2.00 years. I'm starting with that, okay? How many seconds is where I'm trying to go to. So the fun thing about this is I may not know how many steps it is, but I do know when I'm ready to solve 2.0 years, it's got to be there. And then I'm going to try to get to seconds in some way. Can I get directly from years to seconds with the conversion factors I've supplied you? No. In fact, the only conversion factor I see years in is this guy right here. So it looks like we're going to go from years to days, okay? So that's my first conversion factor. I'm going to use it, but I have to put the years on the bottom. Is equal to 365 days. Chugga chugga. That gets us to days. We're trying to take it to seconds. Okay, so days. Where can I go from days to? So we already used this, and sometimes if you want to cancel off conversion factors that you've used, it may make it easier. I see days to hours. Yeah, 1 day is equal to 24 hours. But I'm going to put the day on the bottom. 24 hours. So I can cancel off. We're still not to seconds yet. Okay, hours. Can I get from hours to seconds? No, but I can get from hours to minutes. Let's do that. And every 1 hour, there are 60 minutes. Cancel, cancel. I'm at minutes. Still have to take it to seconds. That is not a big deal. We have one last conversion factor, which relates minutes to seconds. So in every 1 minute, there are 60 seconds. Boom, Boom. And you probably knew silly things like there's 60 minutes in an hour off the top of your head, but I provided it for you here on this problem. So this is actually a 1, 2, 3, 4-step problem, which is super exciting, but we're just going to multiply that 2 times all of the numbers on the top of those train tracks. And if there were anything besides ones, I would divide it by those. Okay, so we are ready. Let's go, let's go, let's go. I have 2 times 365 times 24 times 60 times 60. Boom. Okay, amazing. So I get that fun, fancy number. You're like, oh my gosh, that makes me so nervous. Let's write that. Let's write that. All this number stuff makes me nervous. Okay, that's a giant number. Cool, 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 cool. Okay, oh, how many sig figs? Number in the problem. How many sig figs here? 2. I have to round my answer to 2 sig figs, so start reading it like a book, okay? I obviously want the 6 and I want the 3. Those are my first 2 sig figs, so I stop there. But the conversation that we had in the previous problem, don't you dare 63 me, okay? That is like a number that is like 63 million, not 63. So I have to do what? Put place values of 1s in all of the remaining spaces so we don't accidentally chop off my number. So it looks like behind that 63 to get to the end, I have 1, 2, 3, 4, 5, 6 numbers that are all going to turn into 0. So I will place 6 zeros. I'm not done. I've got to put a unit at the end. This was getting me 2 seconds, and that is what I solved for because it is the only thing I've not canceled off. Okay, amazing. Let's do a couple on the back just to kind of get y'all's brains cooking, and then any remaining ones we don't do on the back practice, you can do on your own. I will give you a lot more practice when I see you guys next time. Okay, so I've given you some available conversion factors here, and once again, showing all work means I need to see your train tracks with numbers and units, crossing off the units as you go along, and then your answer rounded to the correct sig figs and units at the end. Okay, first one, it says convert 74.5 kilometers to meters. Okay, number in the problem, I'm going from kilometers to meters. And some of you guys may be like, this is metric. We've done metric. Aren't we allowed to use the decimal? Yes, I will allow you to use a decimal moving around for metric. But for funsies, I thought I could show you how you could use this with dimensional analysis if I give you, like a conversion factor, okay? So to give you an idea, if I were using the decimal, going from kilometers to meters, I would move the decimal 3 places that way. I would hopefully get a number that would be like 74500, right? Let's see if we get that without moving the decimal, but showing the math with the train tracks. Okay, so I do have a conversion factor that tells me there are 1,000 meters in every 1 kilometer. So this is going to be a 1-step problem, and I told you it was a 1-step problem. Oh my gosh, okay. So my given is 74.5. I'm gonna write km for the metric abbreviation of kilometers, right? And we need the km on the bottom, and then the meters on the top to cancel off, making sure you still keep the number that is supposed to be associated with that unit. So kilometers cancels off. I'm left with meters. So the math is 74.5 times 1,000. And you guys, look, we get exactly that same number that we were expecting to get if we had just simply moved the decimal. So I'm gonna write that. And the fun thing about this problem is as is, that's got 3 sig figs. This still only has 3 sig figs. The zeros at the end are not significant because there's not a decimal in the number. Do not do something silly like put a decimal. So then the units are meters. Cool, 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 cool. All right, I'm gonna do one more. I think one more, but I'm gonna do one more. I'm going to do 2 more on the bottom. Let's do the multi-step conversion problems. I think y'all can handle the 1-step ones, hopefully somewhat simply. This one right here is actually very similar to one of the example problems we did on the front page. So I'll let y'all kind of have fun with that. But I do want to do the last 2. Okay, it says if we are in class for 1.5 hours, how many seconds are we in class? Cool, that's amazing. So we're going from hours and taking it to seconds. I, a lot of times, just immediately get things going, and then I look up at my conversion factors. Hours to seconds. What can I go from hours to that will get me to seconds? Hours. I don't even see it. Oh, they don't even give it to you. I have it on the front side of the notes, but hopefully you guys know that there are, how many minutes in an hour? 60 minutes in an hour, right? And I did that way so I can cancel off. So that takes me to minutes. And now I bet you I can go from minutes to seconds. I can, because I know that there are in every 1 minute 60 seconds, right? Boom, boom. Yes, this gets me from hours to seconds, right? Making sure I cancel it off like you're walking down a stair step or going across a train track in a stair-steppy way. Everything that I have on the bottom is a 1, so all I'm doing is multiplying stuff on the top. 1.5 times 60 times 60. Amazing. I get that answer. And if you would like to round in your head, that is super fine. This guy has 2 sig figs starting off, so I need to round my answer to 2 sig figs. It is already 2 sig figs. Those zeros are not significant. Just don't put a decimal in the number and you're good to go. And the units are seconds. Cool. All right, let's do number 6, and I think we're good. How many inches are in 1.2 times 10 to the 5th miles? Oh my gosh, she's got a scientific notation number. It's okay, we can do scientific notation. So yeah, that scientific notation number represents miles. I'm starting at miles. I'm trying to take it to inches. You were like, oh my gosh, this is overwhelming already. That's okay. I will be using some of the conversion factors hopefully up here to get me to do that. So I'm setting things up. I got my given 1.2 times 10 to the 5th miles. And you can write MI. I just don't know why I kind of back and forth do something new every time. I'm not sure. But let's see where we can go from miles to. Probably not inches. That's a pretty big jump. But, oh, I can go from miles to feet. 1 mile is equal to 5,280 feet. That sounds good to me. I'm going to put the mile part on bottom, right? And then the 5,280 feet on top. Because boom, boom, I'm at feet. I'm trying to get to inches. We know that there are 12 inches in a foot. If you have forgotten, I have provided that information for you. But I'm going to put the 1 foot part on the bottom and the 12 inches on top because I want to go like this. All right, that gets me to inches. We have set this up correctly. I feel confidence in my heart that when I type it into the calculator, I will hopefully get mathematically the right answer. So we are ready to go. You're like, oh, with the scientific notation of it all. That's okay. Remember, guys, our E button takes the place of the times 10 to the. So that means you just have to write 1.2 E and whatever that exponent is, which in this case is a 5. So I have 1.2, and you hit with the second E button, and then you type in 5. Okay, that is good. Now, what am I multiplying that number by? Well, times 5.2 or 5,280. And times 12. And am I dividing it by any one of those numbers? No, they're all ones. And y'all are probably thinking, oh, why did you give all these problems just have ones on the bottom? We're starting off slow, okay? Next time we're going to do stuff with actual numbers on the bottom, and it's going to be totally fun and good. Okay, so whoa, that's a big old number. Not a big deal. Let's see. I need how many sig figs, first of all? I need, 2 sig figs. Remember, scientific notation is just the thing in front of the notation part is significant. So 2 sig figs. Okay, so even just looking at my calculator, I want 7, I want 6. Don't you dare 76. Okay, that's got a lot of actual values after it, so I got to make sure I pump zeros in there as place values. So let's see how many zeros I need. 1, 2, 3, 4, 5, 6, 7, 8, right? I got 8. So we got, or wait, how many? Let me see. 1, 2, 3, 4, 5, 6, 7, 8. It is 8. My eyes are old. Let's see if I did that right. Yep. All right. Amazing. Yes. Just don't put a decimal at the end, and my units are inches. And guys, I could do something fun and crazy if I really wanted to and be like, great, give me this answer in scientific notation. And you're like, Well, remember, scientific notation just has you manipulate the decimal to where it's right behind that first digit and then represents a times 10 to however many number of places you had to move the decimal to get there. So this, if I were to bump it back to get it behind that 7 there, I would have to move the decimal 9 times. So I could represent this as 7.6 times 10 to the 9th, and that's a positive 9 because this is a giant number, not an itty bitty teeny tiny number requiring a negative exponent. It's positive. And the units for this guy are inches. Yes. So that's a potential. Okay. So this was a really good lesson. I'm really proud of you guys. We're going to be using this all year long, specifically second semester. You're going to cruise through chemistry with some of this dimensional analysis, which will actually be more commonly used with the term of stoichiometry. So look forward to that.